Hello, good evening, everyone. Am I audible? Can you just put a comment there? Am I audible clearly? Am I visible? Yeah. So, to just start with the class, just let me know if anyone is there in the class. Just you can just comment and tell me whether I am audible clearly. Am I visible clearly to you all? Can you see that board? Everything is perfect. So, I'm waiting fast. Do comment. Do comment fast. So as we launched yesterday the Power Hour series, so today is the first class for this series, and I'm starting today with unit dimension error analysis. So the chapter is like this chapter is important because every year 2 to 3 questions are asked from this particular chapter, and it's an easy chapter. I can say the scoring chapter where you can easily score 2 to 3. You can easily solve 2 to 3 questions that you are getting from this chapter. So 10-12 marks is there in your bucket. So there is not, you can say it's not a lengthy chapter. There are very few concepts there. So you need to just cover up those concepts and just practice some of the questions, and you are done with this chapter. Okay. So that is how we should proceed in this chapter. So today, like, I'll try to cover up most of the concepts in this chapter, and I have got some questions also in this chapter, like for in this slide. So we'll be discussing few questions. I'll be just guiding you how to solve these questions, and most of the questions are from PYQs and all. So PYQs are there. Some of the PYQs are there, and I have taken some other questions also. So, and I'll be giving you some concepts also. So altogether, it is going to be a perfect. It is going to be, you can say, almost covering all the chapters, all the topics that are asked in question in exam, right? So let's start now. We'll start now. People will keep on joining. So, as I told you, the topic name is what? A unit dimension, unit and dimension, and error analysis. So this session will be of 1 hour. So we'll quickly try to cover up few concepts, and then questions will be doing. So as we talk about the unit and dimension, so first of all, we should understand that whenever we are talking about like different things in physics, so we come across different physical quantities. Physical quantities are those which can be measured, right? If we can measure something, then that will be a physical quantity. So we have physical quantities. Out of that, some quantities are written as fundamental quantities, है ना? And then some quantities are derived quantities. Okay, derived quantities. So what do you understand by fundamental and derived quantities, right? So if we have some quantities, and by using those quantities we can develop a new quantity that will be known as derived quantities. For example, you have momentum. Let's say you have linear momentum and time. So I can write down force as linear momentum upon time. So linear momentum upon time is your force. So momentum and time are used to find out the force. So force is not a fundamental quantity, right? It is derived from momentum and time. Momentum itself is derived from different physical quantities. So like this, some quantities which can be obtained by using some other physical quantities, they will be known as derived quantities, and there will be some fundamental quantities. So if you can remember, we have total 7 fundamental quantities. 7 fundamental quantities we have. Like mass, length, time and all. So we have total 7 fundamental quantities, and then we have a large number of derived quantities. As we go in the physics, we come across different physical quantities, and those quantities can be derived from these fundamental quantities. So these 7 quantities can be used to derive all the other quantities. So I'm calling this as fundamental and this as derived quantities. So, and apart from that, we have two supplementary units also. Supplementary units are there. Supplementary units will be there. For plane angle, we measure angle in radians, plane angle in radians. And then we have one more quantity, that is solid angle. Solid angle is a very useful concept. It is a very useful concept, especially when we are calculating the flux. So sometimes the calculation becomes easy by using the concept of solid angle. And if you remember, that solid angle is what, 2 pi into 1 minus cos theta, where theta is the plane angle and this is your solid angle. So solid angle can be written as 2 pi into 1 minus cos theta. So if you remember this formula, it's fine. Otherwise you can note it down and you can remember this formula, where theta is half cone angle, right? Like this way, this way. And let's say this area is what, dA. This area is dA and this distance is r. So the solid angle here will be written as dA upon r square. And if this angle is theta, so the relation between the solid angle d omega is what, 2 pi into 1 minus cos theta. So it's a very useful concept. We'll be discussing when we'll be doing question based on flux and all in electrostatics. So this is our like fundamental thing, fundamental physical quantities we have. Then we have derived quantities and all. So now coming to that, what is dimension, right? What is dimension? So when we want to write down a physical quantity in terms of fundamental quantities, if then this concept is what we call as dimension of that physical quantity. Let's say we have 7 fundamental quantities and I want to write down velocity. I want to write down the dimension of velocity, right? So how do we write the dimension of the velocity? So first of all, whenever you have to write down the dimension of any physical quantity, just you need to remember one formula associated with that physical quantity. And once you know any one formula related to that physical quantity, we can find out the dimension of that physical quantity, right? Like there are a large number of physical quantities that we encounter in our syllabus of class 11th and 12th physics, and it's like very difficult to mug up all the dimensions, mug up all the dimensional formula, right? It's not that easy. If you have learned it, then it's fine, but it's really difficult to mug up all the dimension formula. So we don't have to actually mug up all those dimensions and all. Just we need to understand the fundamentals behind that how can we find out the dimension of any physical quantity. So I'm just taking an example that if I'm having a quantity that is velocity and I have to find out the dimension of this physical quantity, then I need to just remember any one formula associated with this. And the most fundamental definition for velocity is displacement upon time. So basically displacement is the measurement of length and this is time, right? So if I want to write down the dimension of velocity, it will be simply what? L power 1 t minus 1. So this is the dimensional formula of velocity. So I have taken a very, very simple example of velocity just to make you understand that what I'm trying to do, or what is dimensional formula. So we can take another examples also. We can take other bit difficult examples also, but the fundamental will remain same. You have to just remember one formula related to that. You have to write down that formula, and from there you can calculate the dimension of that particular physical quantity. So let's say I'm having force and I want to find out the dimension of the force, right? So so we always write down in square brackets. Square brackets represent that I'm writing the dimension of that physical quantity. So F is written in square bracket. It represents that I'm going to write down the dimension of force here. Okay. So we know that force is what? Force is mass into acceleration, and acceleration is what? Rate of change of velocity, right? Acceleration is rate of change of velocity. So I've written as V upon T. So I've just written one formula associated with force, and then I'll put the dimension. I'll put the dimension for each of this physical quantity. So for mass it is m power 1. Velocity is just I have written LT minus 1. So this is L1T minus 1. And then we have in denominator T minus T plus 1. Okay. This is T plus 1. So ultimately I am getting m1, L1 and T minus 2. So this is the dimension formula for the force. So you can take up any example. Again, I am telling you the fundamental is going to remain same. And then we are talking about, I'll take one more example to make you understand how this concept works. So if I am taking the example of energy, that you want to write down the dimension of the energy. So then again I told you, you have to remember any one formula associated with this. So I just remember that energy, that potential energy is mgh, right? Do you also remember this formula? Potential energy from the surface of the earth, assuming that at the surface I am assuming the potential to be 0, and if at the surface I am assuming the potential to be 0, then at some height h the potential is going to be mgh. So if the potential energy is mgh, so I am going to write down the dimension of this one. So I'll get the dimension of energy, right? So again, mass is, dimension of mass is m raised to 1. Then g here represent the acceleration, and the dimension of acceleration is what? I'll write down here, acceleration is v by t, change in velocity upon time. The dimension of velocity is lt minus 1, I have written over here, and divided by t. So this becomes lt minus 2. I hope you are following me. The dimension of acceleration is lt minus 2. So g is acceleration only. So this is L1t minus 2 multiplied by h. H is what? Is the displacement, right? So for displacement, the dimension will be what? It is length, right? Measuring displacement means what? We are measuring length. So it is L1 only, right? So this is M1, L2 and T minus 2. So this way we can write down the dimension of any physical quantity. Just you need to remember any one formula, and then you can use the basic formulas and you can find out the dimension of any physical quantity. So I'll be taking one more example to make you understand. Let's say I want to write down the dimension of potential, right? Dimension of potential. You'll be saying that, sir, you are taking easy examples. No, I'm not doing that. I'm just trying to make you understand. I'll take some physical quantities from 12th class syllabus also. You will understand it. So dimension of potential I have to write down. So no problem. I'll just write down the very basic thing. Potential. Have you come across this formula? V is what? Work done per unit charge, hai na? When we define in electrostatics what is electric potential, so what is the definition? The amount of work done in getting a charge from infinity to a particular point in the electric field. That work done is known as electric potential of that point, assuming that potential at the infinite to be 0. So I'm assuming the potential to be 0 at infinite, and from there if we are getting a point charge or a test charge into an electric field against the field, then work done is W by Q. Work done is W and the charge I'm getting is Q. So the work done by Q is what? Potential we are having. And I have to write down the dimension of this one, right? So it's easy, right? It's easy, right? Let me do this one. So I have to write down work done by charge. And you know that work done and energy are related. Work done, we have studied a lot of theorems where we have done that. Summation of work done by all the forces equals to delta K, that is work energy theorem. So we can say that the dimension of work and dimension of energy will always be same, right? Work done and energy are representing almost the same, representing the same thing, right? They are representing energy. So we have already written the dimension of the energy in the previous slide, and that was m1 L2 T minus 2. m1 L2 T minus 2. So work done will be having the same dimension m1 L2 T minus 2. And then we have to write down the dimension of the charge. Okay. So how do we write down current? Current is rate of flow of charge Q by T, right? So from here we can say that Q equals to I into T. Q equals to I into T. And for current, the fundamental quantity is ampere. Ampere 1 and then time into time power 1. So this is the dimension formula of the charge A1 T1. So this is A1 T1. So if I'll write down this one, Okay, I'll be getting what? M1 L2, and then this will go up, then it will become T minus 3, and then A minus 1. So are you following me? That if we have to write down the dimension of any physical quantity, just you need to remember any one physical quantity is formula, and then you can follow the basic procedure to write down the dimension formula. Okay, once we have done this thing, we are able to write down the dimension of any given physical quantity. Then using those dimension, there are certain type of questions which are asked in NEET exam. So I will discuss those few questions here, so you will understand it better. And a few more technique I'll tell you. Let's say if I'm writing, let's say I'm writing pressure plus A into some T square term, right? So it means that I'm adding A into T square with pressure. So both should have the same dimension, okay? A into T square is added to pressure. So we can add only similar type of physical quantities. You cannot add energy to pressure, right? You cannot add force to momentum. So you can add or subtract only similar type of physical quantities. So here A into T square is one quantity, and we are adding it to pressure. So definitely this should have the dimension of the pressure, okay? This should be having the dimension of the pressure. And then T square is, let's say T is time here. If T is time here, so we can find out the dimension of A from here. So this is one type of a technique we follow to solve few of the questions that have been asked in NEET exam. So I'll be taking a few questions. Okay. So we have a question here. The unit of thermal conductivity is. So do you remember any one formula related to thermal conductivity? That what is thermal conductivity? Just think of any formula. I'm giving you 20 seconds of time. Take time, 20 seconds, just solve it, and then I'll be telling you the correct answer for this one. Yeah. Meanwhile, I'll take a sip of water. You just try attempting this problem. Okay, let me solve this question. In heat transfer, have you studied one formula? The rate of heat transfer. If Q is the heat flowing from one end to the other end, let's say ki this is your conductor and it is maintained at some temperature T1 and it is maintained at temperature T2. So the heat energy will flow from higher temperature to lower temperature, okay? The heat is going to flow from higher temperature to lower temperature, and this is the cross section from where the heat is flowing. Let's say the area is A. So, and let's say the Q amount of heat is flowing in time T. So the rate of heat transfer is what? dQ by dt, and that comes out to be K into A into change in temperature upon dx, dt by dx. So if you remember this formula, it's fine. Otherwise, you have to remember it. It's a very important formula. This is from heat transfer. Conduction topic is there. So from conduction, you can expect question in NEET exam. You have to remember this formula. dQ by dt is what? K dt by dx. And this dt by dx term is what I'm calling as temperature gradient. This is what? Temperature gradient. So this is a general term which you are going to encounter multiple times. Like sometimes we also write velocity gradient, potential gradient. So whenever I am saying gradient, it means what? Change in that physical quantity with respect to the length. So here the temperature is changing with respect to the length from one of the corner of the conductor, right? So it is dt by dx. So here what I can do is I need this one, right? I need the dimension of K. So from here what I can say, dQ is heat energy. So this is going to have the dimension of energy. This is having the dimension of time. And this is temperature, so it will be in Kelvin, right? It will be in Kelvin. And this one dx is the length, right? So I have, and this is area. So I have the dimension of all these things. So from here I can calculate the dimension of K. So dimension of K will be written as dq by dt multiplied by dx divided by A and dt. So this is how I have to write down. Okay. So let's check that. Check this one. We'll further solve it. So this is dq by dt. Energy. The dimension of the energy is what? We have done it right. In the second side, this was m1 L2 t minus 2. So I'm going to use this m1 L2 t minus 2. m1 L2 t minus 2 divided by t here, t1, dx is length only, divided by area is length square, and this dt is change in temperature. So change in temperature will have the same unit of same dimension of temperature, and that is Kelvin, right? For that I'm writing K here. So now just simplifying this one, this will get cancelled. So the dimension of thermal conductivity is what? M1 and then L2, and this is L. So this is become L plus L1, and this is T minus 2, and this is T1. So this is T minus 3, and then we have K minus 1. But they are not asking us to find out the dimension. They are just asking us to find out the unit. So I can also tell you the unit for this one. That's not a problem. So if I have to write down the dimension, so we have already written the dimension. This is m1 L1 t minus 3 K minus 1. So if I have to write down in terms of unit, so I'll be using that technique. This is energy per unit time, and energy per unit time is power. Okay. The rate of doing work done is known as power, and the SI unit of power is watt. So this dq by dt will be having the unit of watt, and then this is K, and this is meter square, this is Kelvin, divided by this is meter. Okay, it will get cancelled. So this K will be having a unit of watt upon meter into Kelvin. Okay, so can you think that this is K thermal, right? I should write this as K thermal. Don't write both as K, because here for Kelvin I'm using K, and for thermal conductivity I'm also using the same variable. So you should not do that, right? Otherwise what will happen? You are going to end up doing a silly mistake in your exam, right? So always make a habit that in your question, whatever the variables are given, and you should not repeat those variables. Otherwise you will fumble out there and you will make a silly mistake. So K thermal is watt per meter per Kelvin. So we are having first option as the correct answer. So I have written both the things. I have written the unit, I have written the dimension also. So this is how we can proceed with this type of questions. So as I told you in starting itself, that whatever question we have to write down the dimension, we have to write down the unit. So just you need to remember any one formula for that particular physical quantity, and then you can proceed like this. Okay. So coming to the next question. Okay, here they have asked the dimension of stress. This particular physical quantity have been asked number of times, like multiple times they have asked to write down the dimension or the unit of stress. Okay, so we'll discuss this one. So stress is defined as what? So this particular physical quantity you will encounter in mechanical properties of solid. When you will study that chapter, mechanical properties of solid, so you discuss about stress, strain, Young's modulus, Bulk's modulus, all these type of quantities. So stress is what? Stress is what? Force perpendicular applied on that body divided by area of cross section. So stress is nothing but it is a force which is applied on the body. So basically that is a deforming. Whenever a deforming force is applied on a body, so corresponding to that deforming force, the body develops an internal force. So that is the force here, and it is acting on a cross section area of the body. So this force divided by the area of cross section, and this force have to be perpendicular to this area of cross section. This is important, right? So let's say that I'm having a string here. Okay, I'm having a string here and it is attached to the ceiling, and this is the area of cross section, and I'm considering that this is having certain mass m. So because of its mass, some force will be acting here, mg. Okay, some force will be acting here, mg, and since this mg force is trying to elongate this string, there will be an internal force here, which we call as tension force in the string. So this tension will try to resist this change in the length of the string, and this tension force is acting on this area of cross section A. So in this case, the stress will be written as T divided by A. Okay, so this is how we can do it. So just make a note of it. This tension, this force acting here should be perpendicular to the area of cross section. If it is not perpendicular, then you have to take the component of that force. And if you are not knowing this thing, then you might end up doing a mistake. Okay, so just make a note of it. Whenever you are writing stress, they have to be this force have to be perpendicular to the area of cross section. So now I have to write down the dimension, so that's not a problem, and you will understand that force upon area is nothing but it is the it is also representing pressure. So dimensionally pressure and stress both are same. Okay, dimensionally stress and pressure are the same thing. So force dimension is m1 L1t minus 2. Force is mass into acceleration. So mass is m and acceleration is what? L1t minus 2. So m1 L1t minus 2 divided by area, and area is the square of the length. So from here I am getting m1 L minus 1 and t minus 2. So this is the dimension of stress. Okay, so we can search the correct option here. m1 L minus 1 t minus 2. So C is the correct answer. Are you getting this thing? Yeah. Wonderful, wonderful. You are amazing students. Just keep on working. Just keep on doing your efforts, and definitely you will end up getting good score. So coming to the next, the dimensions of mu naught epsilon naught raised to the power of minus 1 by 2. Again, it's a very important question that have been asked number of times, and what is the tricky part here? I'll tell you. If we'll try to write down the dimension of this this particular quantity by the most fundamental method that I was telling you, that write the dimension of mu naught and epsilon naught, then try to solve it, it will become a bit complicated. Okay, so we have to go through some short tricks, right? So that is the trick I'm telling you here. If you'll study the chapter electromagnetic wave that is in our syllabus, so you'll understand that velocity is what? C is 1 upon under root of mu naught epsilon naught. Mu naught here represents the permeability of the medium, and epsilon naught represents the electrical permittivity of the free medium, like vacuum. Okay, vacuum or air. So mu naught and epsilon naught are electrical permittivity and magnetic permeability. So mu naught is magnetic permeability, this is electrical permittivity, and we have put a subscript naught that represents we are talking about the vacuum, or we are talking about air as a medium. So in this case, 1 upon under root of mu naught epsilon naught, this represents C, and C is what? This is the speed of light. So straight away we have this formula, speed of light. This is speed of light. So just think whatever the situation they have given, this is exactly the same thing I have written here, right? Mu naught epsilon naught raised to the power of minus 1 by 2. It means this can be written as 1 upon mu naught epsilon naught raised to the power of plus 1 by 2, using the properties of exponents. And what do you mean by this? Writing plus power 1 by 2 means it is under root. This is 1 upon under root of mu naught epsilon naught, and this is nothing but the speed of light. And speed means what? distance upon time. So the dimension of speed will be what? It will be LT minus 1. It will be what? LT minus 1. So C is the correct answer. So this is a very, very important question that have been asked number of times. So directly you have to understand, you have to remember this formula, that speed of light is connected with mu and epsilon like this. C equals to 1 upon under root of mu naught epsilon naught. This is how we can write down this one. Coming to the next question. The dimension of half epsilon naught E square, where epsilon naught is the permittivity of the free space and E is the electric field. Okay, do you want to try this question? Yeah. I'm giving you 30 seconds of time. Please do try this question, okay? Then I'll discuss this one. So do you remember what is this half epsilon naught E square? Half epsilon naught E square. What is this thing? Meanwhile, I'll check someone in the class or not. Okay. So have you tried this question? Now it's my turn, right? It's my turn. I'll solve this one. So half epsilon naught E square is what? This is energy density. This is what? Energy density. And energy density can be written as energy per unit volume. Energy per unit volume. So they are asking us to find out the dimension of energy density. So energy density is what? Energy per unit volume. So from this quantity, from this expression, you have to understand that this is energy density, and energy density will be written as energy upon volume. So writing the dimension, now it's easy. Energy is what? We already know. Energy is the same as work done. So this is M1 L2T minus 2 divided by L cube. Now volume is what? Volume is what? Length into width into height. So width is also measurement of length and height is also the measurement of length. So this will be L cube. And this is the dimension of energy density. I hope this is clear to everyone. So write a comment and tell me. So this is what? M1 L minus 1 T minus 2. This is our correct answer. M1 L minus 1 T minus 2. So M1 L minus 1 T minus 2. So this is your correct answer to this problem. Done? Okay. So let's moving ahead. Now they are asking which of the following 5 physical parameters have the same dimensions. So we have to check which all are having the same dimension. So they have given us 5 physical quantities A, B, C, D and E. So see, whenever you have this kind of questions where it has been asked which of the following 5 quantities have the same dimensions, and there are total 5 quantities. So in this kind of questions, you have to first look at all the options, all the physical quantities, what are the physical quantities given. Otherwise, when you will start writing their dimensions one by one, you might up ending taking more time, right? So we should not do that. First, we should analyze all the physical quantities, looking at all the quantity, and then decide is there any quantity which is unitless and dimensionless, so that our efforts gets minimized. So when I'm looking here, energy density, so that I'll write down refractive index. Refractive index is what? Refractive index mu is what? It is the defined as the speed of light in air divided by speed of light in medium. So this is the ratio of two similar quantities. So it is unitless and dimensionless. This is unitless and dimensionless. Unitless and dimensionless. So now we have already written for B. So I'm checking for dielectric constant. Again, same thing. Dielectric constant is what? What is dielectric constant? It is the factor. It is the factor by which force is reduced in a given medium when we are talking about electric field, or it is the factor by which the electric field intensity will reduce in a given medium. So if you will remember this one, you can write down dielectric constant as what? Relative permeability or dielectric constant, both are same thing. So force in air divided by dielectric constant K, that will be force in the medium. So I'm talking about the electrostatic force. Let's say we are having two charges, and initially when the two charges are placed at some finite separation in air, the force acting on the charge was F air, and when that air medium was replaced by some another medium, the net force on the charged particle becomes F in air divided by K. So when you will see here, this K is the ratio of forces in two different situations, right? So K is your dielectric constant, and it is the ratio of the force only, but the force calculated in two different situations, one in air and the other time that force was calculated in a different medium. So when you write down the dimension of both of them, it becomes dimensionless and unitless. So this dielectric constant is also unitless and dimensionless. So I can say that B and C both are dimensionless. So they are having the same dimension. So do we have any such option? B and C? No. B and C is not an option. So again, we have to check further. Few more quantities we have to check. So moving ahead, Young's modulus. Okay. So how do we write down Young's modulus? Young's modulus is what? Do you remember this formula? Stress divided by strain. Young's modulus is stress divided by strain. So after attending this class for approximately last 35-40 minutes, you might have understood one thing, that in order to solve the questions from unit and dimensions, you have to learn all the formulas of the remaining chapters. Like entire physics syllabus should be completed. You should be knowing all the formulas. Then you can solve these questions very easily. If you don't remember the formula, then it will be really difficult for you to solve these questions, because there is no other logic. You have to remember the formula. You have to write down the formula. So I'm just saying this thing again and again, so that you should be having a clear picture for this chapter, that you have to write down the formula, you have to remember the formula, important formula, and then using those formula, this question can be easily solved. So Young's modulus is stress upon strain. Stress is what? Force divided by area, and strain is what? Change in length upon length. So there are different type of strain possible, longitudinal strain, volumetric strain, this kind of things are there. But if I'm writing strain, so strain is what? If I'm talking about when string example. So when you are having a load which is tied to the string and which is fixed on the ceiling, so due to its own weight, mg is acting downward. It is trying to elongate the string. So in that case, let's say due to mg force acting on the string, the elongation produced in the string is delta L, and its original length was L. So the strain which has developed into that string will be delta L by L. So delta L by L is what? Dividing two similar quantities. Delta is also representing length, and this is also representing length. So it again becomes unitless and dimensionless. So Young's modulus is this one, stress by strain, but strain particularly is unitless and dimensionless. It is not having any dimension. So the dimensions of the stress and Young's modulus are same, and stress is having the same dimension as that of the pressure. So pressure, stress, Young's modulus, all are having the same dimensions. Okay. So this is force upon area, and we know that force is m1 L1T minus 2, and that is divided by area, that is L square. So this becomes m1 L minus 1 T minus 2. So if you remember the formula, you can do it very fast. So Young's modulus, the dimension is m1. This is having m1 L minus 1 T minus 2, and then magnetic field. So magnetic field is not a physical quantity, okay? It's not a physical quantity. Not a physical quantity. Understanding this point? Magnetic field is not a physical quantity. Magnetic field intensity is a physical quantity, okay? Magnetic field intensity is a physical quantity. So A is energy density, that was energy per unit volume. So energy per unit volume, and then in the last slide we have written this one, energy per unit volume, that was coming to be m L1 L minus 1 T minus 2, and this m1 L minus 1 T minus 2. So you can see that A and D are having the same dimension. A and D, A and D. So D option is the correct answer. So in D option we have A and D. So A and D both are having the same dimensions. And this will be same to the dimension of what? Pressure, yes. Young's modulus, stress by strain, this is pressure. Energy density, this is also representing what? Dimension of pressure. So if you understand that energy density, this is also having the dimension of pressure. Interesting, right? So different chapters in physics are having different physical quantities, and dimensionally they are this much interconnected. So just again, what I say is, just you need to understand the logic, how to approach just by remembering the formulas. So let's see this question. Which of the following dimensions will be the same as that of the time? Okay. So looking at this L, R, C, L, L, C, R, L, can you just draw an inference from what are these quantities representing L, R, C, L, L, C, and R, L? So these are inductance, resistance, capacitance, है ना? Do you remember that? That DC-LR circuit, DC-LR circuit. So in DC-LR circuit means an inductor and a resistor are connected to a battery, DC battery. Battery means DC source, okay? So what will happen? As soon as we close the switch, initially the switch was open, and as soon as we close the switch, then a current starts flowing into the circuit, and due to the presence of this resistor, the current does not become maximum at once, okay? When this switch is closed, so since this resistor is present there, the current will not become maximum at t equals to 0 time. It will take some time for the current to become maximum, okay? The current will start gradually increasing, and this is an exponential rise in the current. As soon as this is closed, current starts flowing, and with time the current increases and it becomes maximum. So if you understand this concept, and this is we have studied in capacitor topic. Capacitor, or sometimes they teach some teachers prefer to teach in current electricity also. So this is a DC-LR circuit. DC-LR circuit, okay? So here if you will see the equation, I equals to I naught into 1 minus e raised to minus t by tau. This is the equation. So at t equals to 0, at t equals to 0, it becomes e raised to 0, that is 1. 1 minus 1, 1 is 0. So the current at t equals to 0 is 0 from this equation. So I just checked this equation by putting t equals to 0 here. So when I'm putting t equals to 0 here, then this quantity becomes e raised to 0, and anything raised to 0 becomes 1. So this is 1 minus 1, 0. So I becomes 0 at t equals to 0. So that should be the case. When the switch was open, there was no current flowing in the circuit, and as soon as we close the switch at t equals to 0, the current flowing in the circuit is 0. So when the current flowing in the circuit is 0 at t equals to 0, so what is this? This equation is correct. So we can see that the current is increasing exponentially. Current increases exponentially. So what I'm trying to do here is, when I'm getting questions from some particular topic, so I'm also trying to explain you that concept so that you can just remember it, that this was one topic you studied. So I'm just not writing the dimension, or don't take it from that point of view that only we are doing dimensions. So whenever I'm getting a question where I have to write down the dimension of the units, I'm trying to tell you the background story also, that from where it is coming, from where that formula is coming and all. So you will have a better retention for this one, because you are having some background, so you will have a better retention. So I equals to I naught into 1 minus e raised to minus t by tau. So tau here is what? This is circuit constant. This is your circuit constant. Now you see here, this tau is what? This is L by R. This tau is what? L by R. So e raised to something is written there, and it has to be dimensionless, because e raised to something means this should be a number, right? There should not be any physical quantity here. It should be dimensionless, because e raised to some number should be there. It is an exponential function, right? So some number should be there. So t and tau should cancel each other in dimension. So dimension of t and tau are reciprocal of each other. So which of the following dimension will be same as that of the time? So the dimension of t and dimension of tau is same, okay? So dimension of t and dimension of tau is same. And tau is what? This is L by R. Tau is what? L by R. So the first option is correct. The first option is correct. Understood this one? If you are writing, just make a note of it. Write down this formula. Meanwhile, I'll take a sip of water. Moving to the next question. According to Newton, the viscous force acting between liquid layers of area A and velocity gradient. I just told you in the starting that this word gradient will come multiple times. So gradient means what? Change in a physical quantity with respect to length. So, and is given by F, where F equals to minus eta A del V by del Z. So they have given us a formula, minus eta A, this is del change in the velocity upon change in length dz. Okay. N is a constant, it is known as coefficient of viscosity. This is pronounced as eta, and it is the coefficient of viscosity. When we talk about different type of fluids, so some fluids are very easy to flow, some fluids are very difficult to flow, just like jam or honey. They don't have a fluidity. Fluidity is very less, so difficult to flow. It means they are thick fluids, they are viscous, more viscous, whereas water is having higher fluidity and lesser viscosity. So water, when we take water and pour into glass, so it's easily flow, right? It is flowing easily. So it means that it is having less viscosity and more fluidity. So some fluids will be there which are having different viscosity. So a given fluid is more viscous or it is less viscous, it is decided by this quantity which is known as coefficient of viscosity, and it is represented as eta. So now the dimension formula of eta they are asking. So now it's easy, right? we have to write down the dimension formula of eta. So I'll be writing eta is what? F into dz upon a into dv, right? F into dz upon a into dv. So F is force here. So I'm writing the dimension of eta. So the dimension of force is m1 L1 T minus 2. Then it is multiplied by dz. dz is length, right? So this is L1 upon area is what? L square, and dv is velocity, and that is L T minus 1. Okay. So I have written the dimension of all these quantities 1, 2, 3, 4. Force, dz is length, area is length square, and dv is velocity. So this is LT minus 1. So just simplifying this one, I'll be getting the final answer. So this is M1 L2 and then T minus 2 upon L2 into L into T minus 1. This get cancelled. So what I'm getting is M1 L minus 1, and this will go up. This will become plus 1 T minus 1. So this is the dimension of eta I'm getting. M1 L minus 1 T minus 1. So fourth option D should be the correct answer. Coming forward. So this is again one type of question where a physical quantity of the dimension of the length that can be formed out of CG, and this quantity is. So now see, they have asked a very different question here. This is a very important question, right? So it will give you a different idea, different concept, different type of approach how to solve this question. So till now what we have seen is that we are writing the dimension formula of all physical quantities in terms of our fundamental quantities that we have decided. That in SI system we have those 7 fundamental quantities, and all the other remaining quantities are derived quantities. So we always try to write down the dimension of any physical quantity in terms of fundamental physical quantities. But in this question they have given that a physical quantity is having the dimension of length. The physical quantity is having the dimension of the length, but that has been formed out of C, G and this quantity. So these are 3 different quantities. This is C, speed of light, G is universal gravitational constant, and this is some quantity, random quantity E square divided by 4 pi epsilon naught. So they have written this some physical quantity in terms of C, G and this quantity, and it is ultimately having the dimension of length, and we have to find out that quantity, right? So we have to find out that physical quantity. So in terms of C, G and this thing. So this is C, this is G, and this is this physical quantity. So in terms of C, G and this, we have to find out that physical quantity. So what should be the correct approach here? I'll tell you, and just to try doing it. So you understand that the given physical quantity is having the dimension of length. So on the left hand side, I'll be writing the dimension of length, that is L1. On the right hand side, this physical quantity has been represented in terms of Cg and this thing. So I'll be writing C, it is raised to the power of A. Then I'll be writing G, it will be raised to the power of B. And then the third physical quantity is E square divided by 4 pi epsilon naught, and it is having the power of C. So now this physical quantity has been represented in LHS and RHS. In LHS, it is given that it is having the dimension of length. So I have written length to the raised power of 1. Right side, it is given C, G, N. This third quantity, this is some random quantity. So in terms of these 3 quantities, it is having the power of A, B, and C. Now what I have to do is, C is speed of light. C is having the speed of light. So I'll be writing this as LT minus 1 raised to the power of A. Then I have to write down the dimensions of universal gravitational constant. Then I have to write down the dimension of this quantity, and then raised to the power of C. And after writing that, what I'm going to do is I'll compare the dimensions of mass, length and time in LHS and RHS, and by solving that I'm going to get the values of A, B and C, and further solving will get the final answer. So you can try doing it. So I'll just help you out how to write down the dimensions of G and this quantity. So I'm just adding one slide here, and then I'll tell you how to get this one. So we have to write down the dimension of G. So dimension of G is what? That we have to write down. So I know one formula. Force is what? G m1 m2 divided by r square. So from here I can say the dimension of G is what? F into r square divided by m1 into m2. So the dimension of G is what? The dimension of this quantity, right? F into r square upon m1 into n2. So dimension of force is what? m1 L1 T minus 2 multiplied by r square. R is length, so L square, and m1 m2 represent mass, right? So it will be m square. Now just simplifying this one, I'll get the dimension of G, and the dimension of G will become what? M minus 1. Then this is L3, dimension of length is 3, and then dimension of T is minus 2. So we have got the dimension of G, we'll put it there. And one more physical quantity was there, E square upon 4 pi epsilon naught. I'll have to write down the dimension of this one also, E square by 4 pi epsilon naught. So now just look at this one, E square divided by 4 pi epsilon naught. Just look it very closely and you will understand that E is the charge, right? This is written like this, E into E upon 4 pi epsilon naught. Understood this one? So E into E upon 4 pi epsilon naught. This is written. So this is what? 1 upon 4 pi epsilon naught is what? K, electrostatic constant. So this is K, this is charge, this is charge. So this is written as KQ square. This is written as KQ square. So if I divide this quantity by R square and multiply this by R square, this entire quantity will become force. This entire quantity will become what? Force. And this is R square. So from here we can find the dimension of, we can find out the dimension of this quantity. So this quantity is what? KQ square. So I know that force equals to K Q1 Q2 by distance square. So the dimension of KQ square is what? It is F into R square. The dimension of KQ square is what? F into R square. And this dimension is what? Force is M1 L1 T minus 2 multiplied by L2. So this is M1 L3 T minus 2. So I have got the dimension of G, I have got the dimension of this one. So now just we need to put the values there and just solve it. So just solving this, we can get the correct answer for that particular problem. So I'll just, if you want, I can just substitute the values also. I'll substitute the values there. So in the left hand side we are having only L, it is having power 1. Right side, first we are having C, this is LT minus 1 to the raised power of A. Then we have to write down the dimension of G. Dimension of G is what? M minus 1, minus 1, 3 and 2. Minus 1, 3 and 2. And the power is B. And the third quantity is E square by 4 pi epsilon naught to the power of C. So we will write the dimension directly here. So the dimension of this one is M1 L3 T minus 2. M1 L3 T minus 2, and this is C. So now you can just collect the values of all, you can compare left hand side and right hand side. So from here the value of L is A, power of L is A. From here this is 3B and from here it is 3C. The total power of L is A plus 3B plus 3C. Similarly, the total power of M is what? Here it is 0, here it is minus B, and here it is plus C, minus B plus C. And then writing the total power of C, and that is what? Total power of T. So minus A, minus 2B, minus 2C. And left hand side I am only having L. So there is no power of M. So the total power of M have to be 0. So first equation I am writing minus B plus C equals to 0. Then here there is no dimension of time. So this entire quantity have to be become 0. Minus A, minus 2B, minus 2C have to be 0. And this entire quantity have to be equal to 1. So A plus 3B plus 3C equals to 1. So these are three equations. Just solve the values of A, B and C and you will get the final answer. You will get the final answer after that. So I'll just tell you what is the correct answer I am getting by solving this thing. So I tell you the final answer what I am getting. The final answer you should be getting is C option. The option C is the correct answer. Just solve it and you just verify it. I have done almost 99% of the thing I have completed for this one. Just solve it and you will get the answer. So this was a different problem which has been asked in NEET couple of times, where they will give you like you have to take energy, velocity and time as the fundamental quantity, and you have to write down the dimension of all other physical quantities in terms of energy, velocity and time. Or they can take any other quantity and they will ask you to write the dimension in terms of let's say force, energy and let's say some other physical quantity. So like that. So in such kind of questions you have to follow this basic method, that you have to write down in LHS and RHS, take these given quantities as your fundamental quantities and you assume that their dimension to be A, B and C. Then write down the dimensions in terms of our fundamental quantities and then just compare, write the equations, solve it and you'll get the final answer. So that was all from my side for today's session. I'll come up with more interesting sessions in coming time. Stay connected, prepare wisely and put your sincere effort in your studies till your NEET exam 2025. All the best guys. Keep rocking, keep doing.